Hi folks, we have been talking about the switching and fundamentals of TCP/IP and routing and all those things. So today what I want to introduce is IPv6 because previously we have been dealing with IPv4. So today I want to give an easy way of figuring out IPv6. Now as is very clear from the name, V6 means it's not IPv4. IPv4 means 4 octets, 32 bits. Whereas with the IPv6 means it's all hexadecimal and they are 128 bits. Now these 128 bits, if you divide 128 by 4, you will get 32. Now why 4? Because 4 bits means the binary bits is equal to 1 hexadecimal digits. So clearly in 128, all these letters or numbers, whatever you're using, they're all hexadecimal, like 0, 1, 2, 3 up to F. So when you are looking into 0 to F and you want to convert that into binary, it is basically 4 binary bits. So because 0 means 0, 0, 0 and F means 1, 1, 1. So clearly we are looking at is about the hexadecimal. So numbers are going to be from 0 to anything up to F. Now the way we distribute the networks, like in IP4 we did the classes A, B, C. Here they are, just think about the normal things. That if a number starts from 2 or 3, it is a global address, like public address. So that means you can go to the internet. Number 2, if it is starting from FD, that means it is a unique local, like our normal private networks, which we can route, which can do those things, but we cannot go to the internet. And the third category is link local. So link local, just think like Microsoft's APIPA, 169.256. So this is clearly what we are looking at is. So you belong to either global or unique local, or you have a link local address. No, link local address is given to every machine. Doesn't matter whether you have a static address, whatever you do, you may have address from DHCP or whatever you do, every device with the IPv6 gets a link local so that they can talk on the local. Again, remember it is a link local, like APIPA 169.254 and all that. So if you look into that, what I've done is I'm giving you an easy example with the lab. So I have 2 routers, and 2 routers are connected with serial interfaces and through fast Ethernets. So LAN and the serial links. And we know that serial links on a Cisco router, by default, the encapsulation is HDLC. Whereas on the Ethernet, we know it is ARPA. So we need to configure our serial and these interfaces. So what I've done is, what I'm trying to do today is I'm going to use a unique local address. And as I said earlier, if the first 8 bits of your network has to be FD, FD. After that, like normal any IP address, it is 128 bit, 64 is for network ID, 64 for the host IDs or interface. So what I'm doing is, simplest way, you have to just figure out that if I want to do the networking and I'm not going to go to the internet, I just want to do routing and everything. So just pick up any unique local. Make sure that unique local means you have to use FD. You have to start with FD. So if you look into the sheet here, which I'm showing you here on this, IPv6 using unique local addresses. So they are router 1 and router 2. Router 1 has 2 interfaces, router 2 has 2 interfaces. So on router 1, if you look into that, the interface has 0, 0. I'm giving a network ID, FD, colon A. So that means because FD for everyone that is unique local. So I have to say my network ID is A. You can call anything. FD colon 1, 2, 3, 4, 5, blah, blah, blah. You don't have to worry about this one. I just made it simple A. So FD colon A is my network ID. Then colon colon, that means the other side of the host, that means what is the host ID? 1. Just say like normal IP addressing. You say, well, I want to give address to 1 to 254. Same way here. I want to make it very easy. So just say my interface is going to have a IP address FD colon A, colon colon. So this demarcation is for the host. 1/64. You have to mention the prefix so that system will know that which portion is your network ID. So first 64 bits on the left hand side will be the network ID. Similarly, on my serial 000, that means this is on router 1, I'm defining a different network ID because remember, every interface on a router must belong to a different network ID. So I say FD colon B. So basically FD colon B is my network ID. And address IP or the interface, I just give 1. So again, 64/64. Then I go to router 2. And router 2, the interface serial link, I want to call it, if you look at that, FD. And because this is linky, they must belong to the same network. So I'm saying FD colon B. You can see the network ID is FD colon B. And then the colon colon mean demarcation. You want to give the address to the IP, like the device or interface. So that is 2/64. So that means these two are this link. They are on FDB network. This address here is 1 and this address is 2. And similarly on my this fast Ethernet interface, on my router 2, I just gave it FD. You can see there C. So my network ID becomes FD colon C. So basically what I'm doing is I'm dealing with 3 network IDs here. FD colon A, which is on my left hand side, FD colon B, which is my link network, and FDC, which is the other LAN. And similarly, the computers which are going to be on this network, on my FDA, I will just give the address, FDA. And then you go and use, this is what I'm putting it, FD colon A, because this is the network ID. And the computer address, I just say colon 2/64. And the gateway, like normal gateway, you always use the gateway or your side of the interface. So FD colon A colon 1, this. And then on the other side, same way on a computer, PC1, and its IP address is IPv6 basically, FD colon C colon 2/64. And the gateway is this, so that the address of the gateway is, you can see from here, FD colon C colon 1. This is, so I have to make sure it is colon 1. Okay. So now let's look at that when we give the when we use the routing, because there are 3 networks. So there's no way you will be able to come from this side to this side unless you know the path. So what we are doing is on this router 1, I'm defining a default route because we have to go nowhere, wherever I want to go. I have only one outgoing interface, or I have this next hop. So this is the easiest one. We just go and define that IP. This is at a global mode. You have to say IPv6 route colon /0. So this colon /0 means I don't care whatever are the network IDs on the left hand side, the network ID, and whatever the prefix is, I'm going to go and send them through my outgoing interface, which is serial 000. And similarly on this router, which is router 2, because you have to go to this side and you have only one exit point here, either you use your outgoing interface or you can use the next hop, same way as you use IP4. So we say, okay, on router 2, IPv6 route colon /0. This is the default route. So colon /0 basically means like a IP4 when you say IP route 0.0.0.0 space 0.0.0.0. So basically in IP4 we say whatever is the network ID, whatever subnet mask, I don't care. I will use my outgoing interface or I will use the next hop address. This is exactly what is here. So once we have done it, and then we are going to go and test it with the pinging and see how it goes. So let me open my router 1 and I want to show you the configuration. So we are on router 1. So let's go enable. And I want to show you show run. I want to see what I have configured here. So running -config means the interfaces. So if you look at those, right there, interface fast Ethernet 0/0, IPv6 address, FD colon A colon 1/16. Then on my interface serial 0/0/0, IPv6 address FDB, this is the network ID, ::1, which is the host side, /64. And then route, IPv6 route, ::/0 is the default. And my outgoing interface, which is serial 00. And basically I'm done. So if you look into the router 2, so show running dash config, because we want to see what is in. Oh, what is very important thing? The first one is make sure that on a global mode you must run this command IPv6 space unicast dash routing, because routing or unicast is not enabled by default. So you make sure when you are working on IPv6 routing at a global mode, you must type this command IPv6 space unicast dash routing. Otherwise, it won't work. So let's see the interfaces here. So if you look into the fast Ethernet interface, IPv6 address FD:/C. So this is network ID FD:/C. And then : :1, that means the host part, the other part, 1/64. And then let's check the serial link between 1 and 2, router 1 and 2. So you can see that they are sharing this interface, FD:/B, and this side is addresses 2. And remember, serial link, we all know that there is a DTE and DCE. Well, let's not talk about that. So, because you don't have to worry about this one anymore in packet tracer. And then on serial, on my routing, so IPv6, because I'm configuring a static route. IPv6 route space, because the default, I say : remember, : /0 means whatever is on the left-hand side, the network ID side, I don't care. I am not using any prefix, 0. Serial 000, this is your outgoing interface. You can use the next hop address also, but it's up to you. So once you have done it, let's go and check the show IP route command. Because after configuring all that, make sure you go say show IPv6 route. So what is very important, you can see that right on the top, you are seeing static route, this one. And then where it is going to go through your outgoing interface. And then you have your network ID, you can see that FD:/B, where is your own serial link. Link address is all 128, like in IPv4, link address is always 32 there. Here, the system is going to go and match with all 128 bit. And similarly, you have for FDC network. So you have all those networks basically. And then this is your multicasting, FF. So FF is multicasting, FD is unique local. So this is your FDB, this is your FDC, and this is your FD. A is your own. So let's see, we have C, we have B, and this is static. Okay. Let's go check on router here, router 1. So show IPv6 route. So your link is, this is the default. It says wherever you want to go, I don't care. So this is A, this is B, and this is multicasting. And let's look into our computers. So go to your computer, go to your desktop. If you want to, because I want to control things. So you want to control things in an easy way. So your IPv6 address, static FDA, :A::2. You can type anything here if you want. You can fill in all those 64 bits. But why to make life tough? Simple, just keep it simple. And then your gateway is FD: :A::1. But make sure, this is the most significant thing, you must tell the prefix of your network ID, /64 or /48 or slash whatever if you're doing subnetting. And then if you go check the other side of the computer, so you go desktop, go to your IP configuration page, IPv6 address, FD:C:2 /64. That means you are educating or you are telling the computer or the system that my first 64 bit is the network ID. And then your gateways, you must belong same gateway, as we know that from IP4 or even the common networking. So FD:C:1. So let's try it. Let's test it. So if I'm here, let's go and say I want to ping my gateway. So ping FD: my network ID C, and ::1 is the address of my interface, and it is working. Let's go one by one. Let's go and say, can I ping to FD on the other side, which is A, and :2. Oh, we missed the : the last part. FD A: :2, because that will tell the where I want to go. And it's working. You can see that it's going across. You can go trace RT. You want to trace the route. And let's say I want to see how I go to the other computer, which is FD: A: :2. So clearly, system is telling you, oh, well, you are going to go where your FD:C:1, which is your side of the interface, your gateway. And then that goes into its own link, which is FD:B network. And then from there is sending it to FD:A::2. And basically everything is done. So what I gave you is the easy one, very easy example of learning IPv6. You don't have to worry about, otherwise you don't have to say, oh, my address is FD:0 ABCD:1050 ACDE : and then you say ABCD:5607:000. You don't have to worry about those things, because IPv6 basically developed to make our life easy. So just think about the network ID I said earlier. Either your network ID is 2 or 3 global, or FD done, or F8, because each system is looking at those. 64-bit part your network, 64-bit part is your host part. And the host, you can use whatever you want. You can use anything, 1, 2, 3, 4, 5, up to F, or whatever you want. You want to make your life tough, go and do it. So today what I showed you is how we work on IPv6 and how we want to understand IPv6 in an easy way. So I am showing you how to do things with the easy way. You have all the choices of making your life easy, or you want to go through the hard things. It's up to you. So hopefully you enjoyed my lecture and my lab. Try to run it on your own computer. And the next lab, what I'm going to show you, I'm going to mix up the unique local and the link local. So that means I have to introduce 3 routers. And I'm going to go and show you in the next lab. So until then, keep watching my videos, keep subscribing it, and doing it. And hopefully everything will be okay. So in the end, bye-bye.